So first we took 4 pieces of paper. I chose to use 2 and 2, but some people chose 4 completely different pieces of paper. I sorted them out like this. I folded them like this, and then we stapled them at the top. Okay? So let's start in on our notes. You ready? Okay. You're not ready? Almost? Okay, I'm just gonna write and decorate a little bit while you guys are working.
You gonna put a penguin on it?
Maybe.
There's no way you're
All right, what's your high score?
13.
You got 13 staples across the top?
But there could be 14. I just put one.
I won. I have 15.
No way, you're real.
You have the high score now, 15 staples? Okay, so if you guys wonder why you ran out of staples, that's why. Okay.
Well,
Hey, good job, Sam.
my hand slipped.
Your hand slipped 14 times?
Yes.
Okay.
My hand slipped and I stapled my arm.
Oh my gosh. Okay, are you ready? So these are like tabs. We're going to write stuff on them, and then we're going to fold this up like this, and we're going to write notes underneath it. Does that make sense? Okay, so let's start with the first exponent rule. Oh, no, what do we have to start with?
Our name.
Our name. Mm-hmm. Yeah,
I got 7.
please don't write my name on the back of yours. Please write your name on the back of yours. All right, first rule. You ready? Product of powers. Product of powers. What does the word product mean? Multiply. So we're multiplying exponents, right? Well, are we though? If we have a to the m power times a to the n power, if I'm multiplying like bases, what am I actually doing with the exponents? I'm adding. Okay? Okay so far? Okay. So let's fold up this first part. So we're going to have 2 sets of examples, one on this side and one on this side. Okay? X squared times x cubed. What should x squared times x cubed equal if we're following this rule? X to the 5th power or x to the power of 5. Okay? Is this new information to you? No, you already know this, right? Not only did you learn it in Algebra 1 or maybe even earlier than that, but for sure Algebra 1, we've actually already done stuff like this class, right? Okay? So let's talk about the new information part. X to the 3 halves times x to the 4 halves. Is it any different when what we have are called rational exponents? Are the exponent rules still the same? Yes. What do I mean by rational exponents? Rational is another word for what? Have you ever seen that word before? Uh-huh. Look. Rational. So ratio. And ratio is another word for a fraction. Okay? They're called rational exponents. It just means the exponents are fractions. How do I add fractions? Add the numerator, very good, and keep the denominator. Done. I don't know. Any questions about product of powers? The product of powers rule or in either of the examples? You good with that? Okay. Next example or next rule is power of powers. Okay, the next rule is called power of powers. And the rule says a to the m power being raised to the n power. If I have a power to a power, what do I do with those two numbers? I do a to the m times n. I multiply those. Okay? Ready? So x squared raised to the third power should be what? X to the sixth. Very good. And what if I have x to the 1/2 power raised to the third power? So what do I have to do with these two numbers? Multiply them. So if I have 1/2 times 3, is it better if I have it as a fraction? Like 3/1? How do you multiply fractions? Straight across and straight across, right? What's 1 times 3? And what's 2 times 1? So what should this equal then? Very good. X to the 3/2 power. Okay so far? Okay. The next rule is called power of a product. And so somebody might say, didn't we just do that? Well, which one did we just do? Product of powers? Product of powers and power of a product seems like it would be the same, right? But it's not. Think of it, the product of powers, product of two things that are being raised to a power. The power of a product looks like this. AB raised to the m power. The power of a product. Do you see the difference? So if I have A times B raised to the m power, what's being raised to the m power? A? Oh, and B? Both of them? So what should it end up being? A to the m, B to the m. Does that make sense? Okay, let's hold this up. First example is pretty straightforward. AB squared. What should that end up being? A squared, B squared. Very good. God bless you. But is it always going to be that straightforward? No, it's not. Okay, so here's another example. X squared, y to the third, raised to the 4th power. So don't we have to combine the rule that we just talked about, this one, with this one, in order to get the answer? So what do I do with this one, with the x? What do I get? X to the 8th, very good. Y to the 12th. Yeah, absolutely. See, I was just trying to trick you, but you were like, no, we're not letting you trick us. Okay, what about this one? 2xy to the 5th raised to the 3rd power, and y is the first part of the answer, and 8. So when I said what's raised, in this problem, when I said what's raised to the 4th power, you said everything, right? So in this problem, what's raised to the 3rd power? Everything, even the 2, right? 2 times 2 times 2 is what? 8. Does that make sense? People will always remember to raise the x to the 3rd power and the y to the 15th power, yes? But sometimes people forget the 2. Don't forget the 2, okay? So we said x to the 3rd and y to the 15th, right? Okay. Any questions so far? Okay, go over to the other side. What if it's AB raised to the 2/3 power? What should it end up being? A to the 2/3, B to the 2/3. Very good. Now, on this example right here, I'm going to have to ask you to trust me a little bit for a couple minutes. Okay? Because the first part of this you may not understand, and I get it. I just need you to give me a couple minutes. Is that fair? Because I'm just actually going to tell you the answer right here, and actually after we get to one of the other tabs, we'll come back and talk about this one. Okay? So I need you to know that it's 4 a to the what power? 5/2, and b to the 1/2. Are you at least okay with a to the 5/2 and b to the 1/2? You may not understand the 4 yet, but are you okay with the a and b part? Okay, we'll come back to this one in a second, I promise. Okay? Ready to go on to the next rule? Awesome. The next rule is called quotient of powers. Now, what does quotient mean? Oh, divide. Okay. So this rule says a to the m over a to the n. So if I'm dividing like bases, what do I do with the exponents? I do. Absolutely, I subtract. A to the m minus n. See, I knew you knew these rules already, right? Sometimes just seeing the rule is helpful, right? Sometimes seeing examples is helpful. That's why I'm giving you both, okay? Let's fold this one up. So x to the 5th over x squared. What's that going to be? X to the 5th over x squared. X to the 3rd. Okay? Now can I try to trick you? Yes? Okay. What about x squared over x to the 5th? So we can't have negative exponents. Like one of our tabs later on is negative exponents and how to deal with them. I want to have to not even deal with them right here. Where was the bigger number? On top. And I subtracted 5 minus 2, and I wrote down, and I even said that we got x to the 3rd, but what is it really? X to the 3rd over 1, right? Because I simplified the 2 x's in the denominator with 2 of the x's in the numerator, and all that was left was x to the 3rd over 1. Because when I simplified those were still 1s, weren't they? Okay? Well, what if I started where the bigger exponent was? What's 5 minus 2? 3. Well, where did I start, though? So shouldn't I leave that in the answer in the bottom? But what's in the numerator? 1. There was a 1 in the denominator, but I just don't have to write it if it's in the denominator, right? So do you see how this is okay? Do you see if I leave a 1 right here, that's fine? Because then I didn't even deal with negative exponents at all. Okay? So what about rational exponents? X to the 7/3 over x to the 2/3. What's that going to be? Yes, because how do we subtract exponents? Excuse me, how do we subtract fractions? Subtract the numerator, keep the denominator, right? Very good. 5/3. Can you tell me what the next rule is called? Power of a quotient. Yes, power of a quotient. Very good. Power of a quotient. Power of a quotient is the next rule. And power of a quotient says what? What do you think? What's a quotient again? So A over B raised to a power, right? Power of a quotient. So what should happen here? Very good. A to the m power over b to the m power. So now you're telling me not only do you know these rules already, that you could even figure out the names if I asked you? Excellent. Power of a quotient. X over y to the 3rd power. Whoa. X over y to the 3rd power equals what? Uh-huh. Very good. Are they all always that straightforward? No? Okay. A to the 6th over b squared, all raised to the 4th power. A to the 24th, b to the 8th. That's exactly what it would be. X over y to the 1/2 power.
X 1/2, y 1/2.
X to the 1/2, y to the 1/2. Very good. You good? Any questions so far? Okay. So the next tab is going to be the one I told you we were going to have. Negative exponents. Because as much as we don't want to have them, sometimes we get them. And we got to know what to do with them. Okay? So the rule says a to the negative n actually equals 1 over a to the n. Okay? So x to the negative 3rd actually equals what? 1 over x to the 3rd. But what about 1 over x to the negative 4th?
X to the 4 again.
Okay, so what should it be? X to the 4th. Now, people in the past, not you, people in the past have struggled with this rule. Okay? So, I did what I naturally do and made up a dumb story about it to help them remember. Okay? And it goes like this. This x right here, so sad. It is so sad. You know it's sad because its exponent is negative. You, being the kind and generous people that you are, want to do everything in your power to make this x so happy. Where is it right now? Well, it's in the numerator right now, right? There's not a denominator, but there is because it's a 1, right? So when you move it to the denominator, it is so happy. And the negative is gone. Where is this x right now? It's in the denominator, and it is so sad. But when you move it to the numerator, so happy. I know it's dumb. I made it up. Except I can't tell you how many times people were taking quizzes or tests and I hear them go, so sad. If you remember it, isn't it okay, right? If it helps a little bit. So let's make sure we are clear on this silly story and do this problem. Negative 2xy to the negative third. Is the negative 2 so sad? No, it's not. It's probably just like that grumpy old man that yells at you to get off his lawn. Right? We can't do anything about him, can we? That's you? Okay. We can't do anything about him, can we? So what do? We leave him alone, right? He's in the numerator. He wants to stay in the numerator. Nothing we do can help him. So he stays. What about the x? Also happy. Wants to be left alone. And what about the y? So sad. Where does it want to be? In the denominator. When you move it to the denominator, so happy. Now, do you see what we moved and what we didn't? Yes? Only negative exponents can we just move and make happy. All right? Same rules apply to rational exponents? Yes or no? Okay, so where is this? It's in the denominator. So 1 over x to the... So happy. 1 over x to the negative 3/4 power would be what? X to the 3/4 power. What about 5x y to the 2/3 power? Excuse me, negative 2/3 power.
Would we just move the y up and put a 1 under?
So that's my question, right? Because I heard two things. Flip it. Are you, when you say flip it, are you saying the whole thing, flip it?
No. So you make the x sad.
What's the only one that's sad? The y is the only one that we can move then. We have to leave the 5. We have to leave the x. The y is the one we move. And when we move it, so happy. Do you see the difference? Yes? Okay, last tab. Last tab. Other super cool stuff. You ready for the other super cool stuff? I mean, I don't know if you are, but I'm going to try. Okay. So, first thing I want to have written down for you, for your notes, what does x to the first power equal? X. What does x equal if I need it to have an exponent? X to the first, right? These are the same. Why don't we always write to x to the first? Oh, it's too long. It's so much more work to write x to the first than it is to just write x, right? These are the same, though. I need you to be aware of that. Okay? Now, a tricky question is x to the 0. Or anything to the 0 power. It is not 0. It is 1. Can I show you why? I want to draw a picture, and I need you to draw the picture as well so that you can make sure you know it, that you understand it. And it's not, guys, it's not like that kind of picture. First of all, I'm a math teacher, not an art teacher, okay? So stop freaking out. Second of all, I'm zooming out so you can see where I'm starting on this picture, and I'm going to start right here. It's not really in the middle. It's just a little bit lower than the middle, but it's not quite at the bottom. Because I need enough room at the top and I need enough room at the bottom to finish the picture. So now I'm going to zoom back in so you can see what I'm writing. You okay? Do you agree with me that 2 can be represented like this?
I don't agree that a number goes in a picture.
Oh, yeah.
What? Stop it.
Yeah, that makes sense.
2 is 2 blocks, right?
Yeah.
There are 2 of them. What's another way to write this with an exponent? 2 to the first power, right? Is everybody in agreement on that?
Yes.
So what does this mean? There's 4 of them, right? Well, you know 2 squared is 4, but I'm saying, like, the area model, what am I actually doing with this area model? I'm doubling it, right? So I have what I had before, and then I double it. So how many blocks are there? 4. Does that make sense? Well, what does this mean? I double this again. So I take what I had before. That's what I had before, right? And then I double it. So how many are there now? 8. And then, what does this mean? Double it again, right? Double this one. So I take what I had before, and I double it. So how many blocks are there now? 16. Oh, everybody okay so far? Do you see any patterns here? What's one pattern that you see?
It's counting by 2.
It's counting by 2s. Okay, so what do you mean it's counting by 2s?
Like 2, 4. But
Oh, so over here.
6.
So 2, 4, 8, 16. So it's really not counting by 2 so much, but multiplying by 2. Does that make sense? That's what you meant, right? Okay, good. So it's multiplying by 2. If I start here and go this way, it's multiplying by 2, right? What other patterns do you see? Oh, the exponents are increasing by 1, right?
Yeah.
Okay. Now, those were great patterns that you saw. I'm glad that you saw them. Can we go the other way? Are there patterns the other way? What if I start here in the exponents? Counts down by 1 every time, right? What if I start over here on the number of blocks? What happens? I divide by 2 every time, right? Well, if I'm going 4, 3, 2, 1, isn't the next logical number 0, 2 to the 0? And if I'm dividing by 2 every time, divide by 2, divide by 2, divide by... What's this divided by 2? 1. What's 2 to the 0 power? 1. It's 1 block. Does that make sense? Can we keep that pattern going? What if it's... What would be the next one right here? -1, right? And if this was 8... Sorry, this was 16... And this was 8, and this was 4, and this was 2, and this was 1. What should this one be? Isn't it half of that block? So wouldn't that be a half? Let's go one more. Wouldn't that be -2? Here's the other pattern that we didn't talk about. What shape is this?
Square.
A square?
Rectangle.
Rectangle?
Square. Rectangle. Square. Rectangle.
This one should be a square, right? And it should be half of that, which is what? 1/4. Is 2 to the -2 really 1/4? Well, it's so sad right now, isn't it? And when I scoot it to the denominator, it's 1 over 2 squared. Well, what is 2 squared? Oh, look, 1/4. Okay? So first of all, we need to talk a little bit about patterns. Make sure you guys are still okay recognizing patterns. But the main goal was for you to see what 2 to the 0 is. Do you understand with this area model why 2 to the 0 is 1? Does that help a little bit? Okay? There's a couple more things we need to talk about for right here. Okay? This one is kind of a big deal. And when I say kind of a big deal, I mean actually a big deal. A to the m over n power. It's like our new thing for today, right? Our fractional exponent stuff for today. When you have a fractional exponent, the top of the fraction is the power. And the bottom of the fraction, or the denominator, is the root. So what I mean by that is if we have x to the 1/2 power, what I'm actually asking you about x is what is the square root of x? See, it's x to the first power, but it's the second root or square root of that number. Does that make sense? And if I had y to the 2/3 power, the 2 is the power, the 3 is the root. So what am I actually doing? What kind of root am I taking? A cube root of what? Y squared, yes. Does that make sense? Well, if it makes sense, please go back up here with me to my power of a product. Remember I told you we would come back here, right? In my power of a product, I ask you to trust me on this one right here. Remember, this is the one where we take everything inside to that power? And what I said was 16 to the 1/2 power was 4. Is that right now? Does that make sense now? Because what am I asking you to do to 16? The square root. Does that make sense now? All right, any questions about this?